I have a question. How long does it take to lose your drink to the sun? It's 95 degrees today. If I left this full cup outside and came back in 4 hours, it would be empty. Which had me wondering about bigger bodies of water, like reservoirs. According to the United States Geological Survey, reservoirs in the US cover almost 15 million acres, about the same size as West Virginia. As large, open areas of water, reservoirs can lose a significant volume to evaporation. In fact, a 2022 study found that globally, evaporation from lakes annually is estimated to be equivalent to the volume of 3 Lake Eries. That's a lot of cups. This has massive implications for our water resources, many of which are already under pressure from climate change, population growth, and overexploitation. So, how much potential drinking water are we losing through evaporation? Let's find out. Hi, I'm Stephanie Andrews,
climate scientist,
ocean adventurer,
and systems specialist at NexSens. In the southern state of Texas, where warmer climates prevail, understanding evaporation rates is key to ensuring the security of water supply. Every child learns about the water cycle in grade school, but measuring evaporation scientifically is hard because there are so many factors involved. And science has come a long way since what goes up must come down. In the 1950s, Class A evaporation pans were adopted as the standard pan for measuring evaporation from a water body. Bear with me. These rudimentary stations are basically pans of a uniform size that are filled with an agreed amount of water at 9 a.m. each day. When they were refilled the following morning, the amount of water remaining in the pan gives an estimate of the previous day's evaporation. Of course, there's a lot of uncertainty in this method. It assumes there's no other water gain, for example through precipitation, although some pan stations do have rain gauges nearby to account for this, or water loss if a thirsty cow wanders past or a bird decides to take a bath. Even so, these Class A pans have been accepted as a standard method of measuring evaporation in the US, Australia, and many other countries. In the 1980s, pan-to-lake coefficients were developed that enabled experts to extrapolate data collected from lakeside pans to estimate evaporation rates from the lakes themselves. These still had a lot of uncertainty, and in the 21st century, we've been able to do better. Thanks to technology, experts have been able to collect more accurate data at higher frequency, using methods that are less susceptible to sabotage by passing cattle or birds. The Texas Water Development Board is the state agency charged with ensuring a secure water future for Texas. In 2018, teams at the Development Board established an experimental floating eddy covariance station. In a nutshell, this analyses gases in the air and their pattern of movement, then uses a statistical method to estimate evaporation rates. With more direct measurements, this experiment gave the TWDB team an insight into how climate conditions affect reservoirs. But they didn't stop there. The Development Board received grant funding to develop an evaporation rate monitoring network across 4 major water supply reservoirs. A total of 4 NexSens CB650 buoys were deployed on Lake Buchanan, Choke Canyon Reservoir, Lake Meredith, and Red Bluff Reservoir. Each system was equipped with meteorological and water temperature sensors, which continuously collect the data needed to estimate reservoir evaporation. The buoy stations report meteorological and water temperature data at 5-minute intervals, syncing with the TEX Mesonet data reporting frequency. Getting data from monitoring stations out on the water is critical to actually understanding conditions and accurately estimating evaporation rate. Wind speeds and dew point temperatures measured by the buoys differ from the land-based pans, and they've also observed evaporation spikes during wind gusts. Having data on actual conditions, shoreside and on the lake itself, enables more accurate correlation of evaporation rates and is being used to calibrate and validate a new modelled reservoir-specific evaporation dataset for Texas. It's also being used to update the legacy pan-to-lake coefficients for the reservoirs that have both a pan station and a buoy. The buoys also collect data on temperature throughout the water column and solar radiation. This data helps estimate reservoir energy budgets. That's the balance of energy leaving and entering the system, and provides further validation for other research. The knowledge gained from the growing dataset on Texan reservoirs is of immense operational importance, helping guide water management decisions that will ensure water security. The National Centers for Environmental Information's analysis suggests that 2024 was the warmest year on record for the contiguous United States. Facing challenges of climate change and warming average temperatures, the continued development of technology and methodologies to accurately constrain evaporation rates will be even more important. Visit nexsens.com for more information. NexSens. Better data. It's never been easier.